All right, good afternoon, everyone. We'll get started. Welcome to how to achieve a self-service and secure multi-tenant data lake in a large company. My name is Leon Lee, platform architect at Northrop Grumman Corporation. In case you don't know about Northrop Grumman, we are a global security and defense company. We have about 100 years of technology and engineering innovation experience, starting from constructing the Spirit of St. Louis in the 1920s, the first solo flight across the Atlantic, to in the 1960s, we built the Apollo lunar module that landed on the moon. But more recently, we've been having a lot of stealth technology improvements and space exploration. So today, Northrop Grumman works on thousands of contracts and programs with many government and commercial customers worldwide. In terms of analytics, we have a very diverse set of analytics fields. Autonomous systems, rockets and satellites, command and control, cybersecurity, logistics. These are just a small number of the fields we work with that are involved in analytics that I can tell you about today. Because we have thousands of programs in the different diverse fields, this has resulted in Northrop Grumman having a very complex set of analytics needs and analytics capabilities. Now, the lessons that I want to share with you today come from my group's work in developing Northrop Grumman's enterprise-wide big data analytics platform. This analytics platform is deployed within Northrop Grumman, available to all of our employees. It has capabilities ranging from basic infrastructure provisioning to big data handling to state-of-the-art machine learning. The data lake portion of this platform is implemented as an enterprise-scale, single shared Hadoop cluster with multi-tenant security. So what does that mean to us? Multi-tenancy means to us that different users and different groups in the company all share the same Hadoop data lake, but the system has the ability to logically separate or segregate the data by user and by group. This is very important to us. As a defense company, we must have the ability to control who has what data and how. And importantly, the sharing of data between users and groups in this platform is implemented as an explicit governance choice rather than open sharing by default. And so the combination of providing good analytics capabilities and good security governance is very important for a defense company like ours. And we would like to have both valuable analytics results, but it's also to keep the data safe. Yes, before we go ahead, I was required to show you this slide. Basically, it says that neither I nor Northrop Grumman is going to endorse any products, open source or commercial. There's, after all, some things I cannot tell you about. So today, I want to focus on some technical architecture lessons that my group has learned while dealing with Hadoop security. Over the past several years, the Apache community and others have really done a lot of work in making Hadoop more enterprise-ready, and that includes the enterprise security portion. It is now, in my opinion, more feasible than ever to stand up a widely used secure enterprise Hadoop cluster inside a large company or a large organization. But today I want to talk about three different areas: authentication, authorization, and interfacing analytics applications that has some trade-offs and complexities so that hopefully this will help in your analytics adoption journey. So Hadoop, in its secure mode, uses Kerberos for authentication. So quick show of hands, how many of you guys have set up a Kerberos-enabled Hadoop cluster? Most of you, OK, good. So some of this stuff is going to be a bit of a review for you. And so you know that Kerberos is going to be a little bit difficult to work with, a little bit complex to configure. But the concept is really simple. You have each user has a Kerberos account. Each service has a Kerberos account called a principal. And both the user accounts and service accounts will authenticate to a centralized location called a KDC, or key distribution server, right? And the KDC is the centralized location where administrators are going to manage accounts and secure credentials. Hadoop is obviously not the only system that uses Kerberos, but the particular issue with Hadoop Kerberos is that there's a relatively large number of Kerberos principals that are needed. Each user that interfaces with Hadoop needs to have a Kerberos account. And each service on each Hadoop node also requires a Kerberos account. So when you deploy an enterprise-wide Hadoop cluster, a key question is, how are you going to manage all these accounts, and how are you going to deal with them? So even for a moderately sized cluster, you could easily get hundreds or thousands of accounts that you have to control inside just service accounts. And in large companies, as you probably know, it's not good to always stand up a separate KDC or a separate IAM system for every time you want to create a new system, right? We don't want every system to have its own set of accounts. That ended about 15 years ago. Account management today in large companies is usually the job of the centralized enterprise identity and access management group. This group does a lot of work from account provisioning, deprovisioning, handling password resets, and then less visibly ensuring compliance with regulations and audits. So by design, Kerberos is the underlying system, underlying technology for most of these enterprise IAM systems. If your company uses Windows Domains and Active Directory, or perhaps Red Hat's IDM server, or even if it's just an open LDAP plus KDC implementation, these are all examples of enterprise tools for managing centralized accounts throughout the organization. So when deploying secured Hadoop clusters enterprise-wide, it is important to consider how your Hadoop cluster stores user and service accounts, and then exactly what is the relationship of that storage in relation to the enterprise IAM organization. This is not just because you need it for compliance reasons, but also because as the number of users and use cases increase, it's very important to leverage these enterprise IT resources. There's a couple of ways you can do this, right? The first one is the completely isolated account management approach. So in this case, you can simply create a separate identity and access management system, so a separate KDC, and you can put all your Hadoop service accounts into there. This is the most straightforward from a setup perspective, right? Minimal configuration. With minimal configuration, you can get Ambari or Cloudera Manager to create service accounts and automatically put them into your Hadoop IAM system and automatically distribute them to all of your Hadoop nodes. Now, the new separate IDM that you've created, because it is not encumbered by any existing processes or existing applications, this is the fastest and most straightforward way to set up a Hadoop cluster that's got enterprise security. And also one that requires the least specialized knowledge in your organization. But of course, there's no free lunch. Each Hadoop user in this architecture has to have its account provisioned separately, and that would be by your separate platform operations group. So this means that you have to then deal with provisioning accounts, deprovisioning accounts, handling password resets, dealing with the auditing and compliance that come from these challenges. Users are also inconvenienced by this architecture. They have to remember two separate accounts, one for Hadoop and one for everything else. If your users write an analytics script, let's say using Bash or R or Python, something that happens very commonly, the fact that they're going to need, let's say, 2 or more accounts to access 2 or more data systems almost always means that you have to hard code passwords in plain text in the script. That's quite a security vulnerability and generally not a good thing. And so finally, in some organizations, in regulated industries, you're just going to run into major compliance problems that you can't solve using this architecture. So an alternative authentication architecture is to put all of service accounts into your enterprise IAM system, right? So this is pretty great from an account management perspective, from a user account management perspective, because now you don't have to worry about this at all. All the Hadoop users are already defined by your enterprise IAM team. And then all user management, all the provisioning, deprovisioning, compliance, password resets is simply done by a different team as part of the normal day-to-day enterprise IAM activities. The users also like this because they get to have the same account to log into Hadoop as they log into other systems. And then what I talked about earlier, right? If you write a script, the platform provides a single sign-on that this kind of architecture provides you will have a strong benefit in terms of security. So imagine being able to log into your laptop in the morning and automatically be authenticated into Hadoop. That's what this architecture allows you to do. And then, of course, removing the Hadoop IAM removes one potential source of system failure. So that's one less you have to worry about. Now, for the downsides, whether you can do this depends a little bit on your specific organization. A challenge is that your organization is the enterprise IAM process going to be compatible with putting in hundreds or thousands of Hadoop service accounts to that IAM system. Remember, it's not just a setup case. Once you, obviously, in the first setup of the Hadoop cluster, you do have to put a lot of service accounts in there. But every time your Hadoop cluster expands, every time you swap out hardware, every time your topology of services changes, you have to maintain the service accounts that are inside the enterprise IAM system. So the question to ask yourself, how much compliance or process approvals are needed to get Ambari or Cloudera Manager to have enough administrative rights to interact with an enterprise IAM system? That's a question that you have to ask yourself, whether or not this architecture is feasible for you. In some highly regulated industries, it could be pretty challenging to do this one. Another kind of a hidden disadvantage or an advantage, depending on where you are in what your organization looks like, is by having your Hadoop cluster joined to an enterprise IAM system like this, you're essentially putting every Hadoop cluster node into the same domain as your enterprise IAM system. And for example, if your organization has Windows Active Directory as your primary IT system, then this architecture means that the Windows group policies may affect your machines. Whether that's a good thing or a bad thing depends on your particular organization. So it could be a good thing because a lot of security policies apply. It could be a bad thing because a lot of the security policies you don't want applies. Now, the two approaches that we've discussed so far can be combined into a hybrid approach. This is probably the most advanced approach, where the Kerberos protocol that underlies Hadoop, IAM, and the enterprise identity access management can be used to split management of accounts. So in this particular case that I have drawn here, we have the Hadoop service accounts being placed into a Hadoop enterprise IAM system. I'm sorry. The Hadoop accounts are placed inside the Hadoop IAM system, and then the user accounts are still managed by the enterprise IAM system. In this case, a Kerberos trust is created between the two domains that lets users from the IAM system, from users from the enterprise IAM system to directly access and authenticate into the Hadoop cluster. What's happening in this hybrid infrastructure, this hybrid architecture, is essentially you're splitting your identity access management system, you're splitting your KDC into two. And managing them separately. The Kerberos does support this mode, but it's a pretty advanced mode that can get you some benefits. In this architecture, your enterprise IAM manages user accounts, like I said, and your Hadoop administrators are still able to manage all the Hadoop service accounts. Your users also still get single sign-on, so it's really the best of both worlds in terms of the previous two architectures. But there is going to be a disadvantage with this architecture. The Kerberos trust requires special knowledge to set up. Kerberos, as you probably know, is fairly difficult to work with, to configure and debug. In a large enterprise, having the Kerberos trust could really create some challenges. Server management, firewalls, networking, DNS, InfoSec, and client tools in many large organizations are different teams. And so imagine trying to debug a Kerberos configuration issue across 6 or 7 teams. So that's the downside of choosing this capability, the complexity of the configuration, the complexity of the debugging. Another issue that could come up is that if your enterprise IAM system has a different operating system from your Hadoop IAM, you could get some interesting compatibilities as well. For example, Windows and Linux incompatibilities can occur even if the Kerberos protocol is the same. So if you choose this option, please be mindful of those kind of issues. And then finally, this challenge with Kerberos trust does extend to applications. When you have applications joined into this case, the applications have to first authenticate the users and then authenticate those users into the Hadoop cluster. This creates what's called a Kerberos double hop delegation problem that requires, again, special skills and special capabilities to be able to solve. All right, so in summary, for authentication and Hadoop enterprise integration, we've talked about 3 different options. So your choice will be quite important here. It determines whether users can use single sign-on. It determines whether users can use even their normal enterprise login accounts to access Hadoop. It affects how quickly your users can provision access and start becoming productive on your data platform. It affects how easily your Hadoop-based data lake can be configured and scaled, how your company or organization can manage compliance issues, and as we talked about, it can even affect the security attack surface of your overall system. And I wish I could tell you that one of these is best. The reality is that it's unclear. The reality is that each one of these choices can work well in some organizations, but not others. My recommendation to you is really to start the process early and to coordinate very closely with your enterprise identity access management organization to determine which one of these is best for your organization. It's important to put some time into this because once you have a large number of users and use cases in your Hadoop-based data lake, it is rather difficult to change this decision. So now that we have looked at authentication, next I want to spend some time on authorization and access control. So as the number of users and use cases grow in your organization, it gets increasingly important to consider which users should have access to what data. Now earlier I talked about in my company, it's important to consider multi-tenant security, the ability for the systems to segregate data access by user and by project. Even if that's not the case, imagine having a large number of users and then user A can delete user B's data by mistake. So as the number of users increase, you always have to think about some kind of authorization controls for your data sets on the system. The modern way to do Hadoop authorization is to use an authorization plugin system. So for this, if you're using the Hortonworks stack, this would be Apache Ranger. If you're using the Cloudera stack, this would be Apache Sentry. Now, there are many different online articles and demos to talk about the details of how to configure Ranger and Sentry, so I won't be doing that demo here. But essentially, Apache Ranger and Sentry are just ways to apply access control lists to Hadoop resources. The way it works is that when Ranger and Sentry is installed on the Hadoop cluster, plugins are added to each Hadoop component, which intercepts the requests and ensures that the access control list the administrator has specified for each component is followed. Right. And it gets quite fine-grained, which is a good thing. So for example, for Hive databases, it's possible to set permissions for users and groups all the way down to the table column level. So you can do quite a lot to specify which users have access to which columns of data, which specific files, which specific queues, and so on. And these fine-grained controls on Ranger and Sentry cover many of these components that I've listed here. And using these, it has been our experience that it's possible to comprehensively manage access to Hadoop resources across an entire enterprise Hadoop data lake. Generally, Ranger and Sentry works very well, but there are some important caveats that I want to tell you about based on the architecture of Hadoop that can lead to some surprising behavior. And the surprising behavior here comes from the fact that Hadoop services are often built on top of each other. In the early days, Hadoop did not have an authorization system. Ranger and Sentry are added after the fact. And so in the early days, a lot of the dependencies are set in terms of how Hadoop is architected. And that can lead sometimes to clients interacting with Hadoop services in a way that cause certain Ranger plugins or Sentry plugins to be bypassed. This architecture here is an issue that has come up pretty often. So as you probably know, Hive databases is a distributed database system. The data for Hive tables actually just resides in Hadoop files and Hadoop folders in HDFS. And in Hive, there's a meta store, which is just a store of schemas that enables the Hive server to understand what is the structure of each table inside the database. When you access a Hive table via the Hive client, the execution path goes through Hive server, Metastore, down to HDFS. This passes through 2 Ranger authorization plugins, the Hive plugin and the HDFS plugin. So both of these policies, right, the Hive authorization policies and the HDFS policies apply. There's actually a configuration switch that you can set in there to configure whether you want it to be an AND relationship or relationship. But if you use the Spark client to access a Hive table, something different happens. The Spark executors will access HDFS Hive table content directly and then use the Hive metastore directly. This bypasses the Hive Ranger authorization plugin, so only one set of policies apply. So this means that there's going to be a trade-off between how you implement authorization controls for Hive databases in your Hadoop-based data lake. If your organization only uses Hive, but not Spark, then you should use the Hive authorization plugin. You're going to get finer authorization. You're going to get more finer authorization features, and it's simpler to manage. But if, on the other hand, you want your users to access data through Hive services as well as Spark queries, then it gets a little bit more complicated. You have to then consider whether you will need to use the two plugins simultaneously to determine what your users see. You have to decide whether it's acceptable to your organizations that users are going to see two different sets of authorization for the same for the same data, depending on whether they access the data through Hive or Spark. This is a fairly difficult issue to deal with. We've struggled with this one actually quite a bit. There probably is no super great solution, but the take-home message really is that the Hadoop authorizations are generally very powerful and they work very well. But in some cases like this, they do have surprising behavior. So it's important to consider the authorization architecture before you roll out a service, test it out from multiple angles to make sure that the authorizations work as the way you expect. All right, the final topic that I'll be discussing today is how to interface external analytics applications and software into Hadoop. Traditionally, most users interacted with Hadoop using command line tools. And these command line tools can be used for everything from managing files in HDFS, running Hive queries, kicking off MapReduce jobs, managing the Uzi scheduler, Spark, Hive, Uzi, Kafka. All these have command line tools. Now, the command line tools are great and powerful, and they're still in use today. But really, any good enterprise-wide deployment of Hadoop data lakes can benefit from some graphical tools. Right? So graphical analytics tools today have become more mature. They obviously, when you interface them with Hadoop for analytics, can give you better visualizations. But we also find that having graphical tools allows more citizen data science type of users to be involved in your analytics process. Now, citizen data scientists are those users who have the strong desire to make use of data and to do data-driven decision-making in your company, but they don't necessarily have the strong programming skills that are needed to work with raw command lines and programming languages. So we find that providing a graphical analytics tool with faster to learn capabilities, like a drag and drop capability, can really speed up adoption of your data lake in the company. So examples of some of these graphical graphical type of tools include data science notebook capabilities, such as Jupyter Notebooks, Hue, Zeppelin, RStudio. And there can also be some business intelligence and visualization tools from the commercial world, things like Tableau, Alteryx, Power BI, and Qlik. And again, I mentioned these as commercial tools and open source tools, not as endorsements, but just as examples of the type of tools that can connect to Hadoop. Now, you're going to find that your data science users and data engineering users are each going to have their favorite data analytics tool, and they're going to want you, the platform team, to adopt it and to include it into the data lake. And naturally, most of your users will evaluate the analytics features of the software and not on the security and governance side. And so therefore, as platform architects and engineers, it is up to our job to do this kind of security and governance evaluation. You will find that not every analytics software out there can be securely connected to an enterprise secured Hadoop platform. You will also find that not every method of connection can be used for every software tool. Nonetheless, it's important to understand what are the different configuration and interfacing methods so you can evaluate the applications that come across your desk. So the first one of these methods is called Hadoop secure impersonation. This is a Hadoop feature that allows service accounts to be given the ability to impersonate other accounts. Usually this is useful for connecting web applications into Hadoop securely. Some examples, Apache Hue and Apache Zeppelin use this kind of capability a lot. What happens is that an application has a user log in into the web application, and then subsequently, every time the application does a task on behalf of the user, it simply informs the Hadoop cluster that I'm impersonating the user. And this is how this secure mode works. One of the benefits of this type of architecture is that generally, web applications that use secure impersonation are multi-user applications. That means you simply deploy one instance of a software on the server. It can then serve multiple users in multiple different sessions that all have the correct authentication capabilities into Hadoop. That's a very important thing if, from a perspective of managing applications inside your organization. The only real caution to this approach is make sure that you limit applications that have these super user privileges to trusted applications only. It can impersonate a lot of users, and it doesn't always leave a log trace in your central IAM system when it does. So make sure you understand how to deal with that in your organization. So Kerberos direct authentication is another method that applications can connect securely into Hadoop. So here, the users run kinit to first authenticate themselves into an IAM system, or a KDC server, as I've drawn there. That brings in Kerberos tickets to be stored on the user's computer. Then the application that the user runs will use that ticket to authenticate into Hadoop services. So essentially, from the Hadoop cluster's perspective, everything the application does after that point uses the user's Kerberos ticket, and therefore originates from the user. And applications that make use of this method include all of the Hadoop command line applications that we've seen, your HDFS tool, your Beeline, Spark Shell, all use Kerberos direct authentication as the primary mode of secured authentication. There's also going to be some data science notebook tools that can do this. Personally, Jupyter notebooks I've seen do this quite well. There are going to be some downsides to Kerberos direct authentication. First of all, users need to be trained to be Kerberos aware. A lot of times they need to know how to run kinit and kdestroy and what that means. For a very big enterprise deployment of Hadoop, that's sometimes difficult. It's great when it works because Hadoop is probably it's great when it works because Kerberos is probably the most secure of all the authentication methods. It leaves the most amount of logs in the enterprise IAM system. And so it works. When it works, it's great. But trying to convince thousands of users that they need to become knowledgeable in Kerberos could be a major challenge in your organization. There is also some choices of IAM systems that make this very difficult, depending on how many hops you jump through. You'll find that if you try to use the hybrid identity management approach that we discussed in the first section of this talk. Another potential downside I neglected to list here is that applications that use direct Kerberos authentication tend to be single-user applications. What that means is it works well when you have a user install the applications on their laptop or you provide them with a virtual machine. It doesn't usually work well if you have a server application that does this. That means that if you're going to run this kind of tool on your network, you have to think about how to handle a very large number of client tools on users' machines. But that said, recently, we've started seeing an extension of the Kerberos authentication method to extend to multi-user tools. This architecture is a little complicated, so I'll walk you through it. What happens is that the user here authenticates first to an application server and then provides a password or Kerberos key tab to that server, which is then saved. Every time the user now needs to run an application, the application server will start a user session inside a Linux container. That Linux container as part of its startup process, will then communicate with the KDC server to obtain Kerberos tickets. And from this point on, the user interacts with the application inside the Linux container session to do all Hadoop tasks. as him or herself. Examples of this kind of application include some commercial data science type platforms. This one I really can't tell you in public which these ones are, but you'll see it if you start to talk to some of the folks outside about exactly how their multi-user applications data science commercial platform works. The major benefit is that the Kerberos authentication becomes transparent to the user, and this really improves user experience when users don't need to know how to do kinit and kdestroy. And of course, the Linux container security simplifies the isolation of many analytics applications. In fact, this is a really great way to make a lot of single-user applications that are available for data science today into multi-user applications. The caution here is most of these platforms will save the user's Kerberos password or Kerberos key tab. And that is generally okay if it's securely handled. So if you have, I think it's generally okay if it's securely handled. Your organization might think differently. The thing to do here is if you run across an application that does this and you like the features that it has, make sure you understand the way that those passwords are saved, where they're saved, and who has access to those application servers. Because these are essentially enterprise IAM passwords. It could even be a main account passwords for your for the users in many different enterprise systems in your company. A breach here could be very bad in terms of your enterprise security. And the last architecture that I want to talk about for applications is the edge proxy gateway. Now, the most common here is the Knox application gateway. This is a reverse proxy API that sits on the edge of a Hadoop cluster. And this reverse proxy essentially takes Hadoop API calls with a very large variety of different authentication options that then translates them into Hadoop service calls. The idea here is that this is a bit of a translation mechanism. You can have a lot of different pluggable authentication providers, everything from claims to PAM to cookies. I'm pretty sure I saw a demo out there where somebody put multi-factor authentication into this type of architecture. This is fairly useful if you're writing custom scripts that call Hadoop functionality. We're not seeing a whole lot of existing out-of-the-box applications that do this kind of plug-and-play authentication providers yet. I think I looked about a month ago. Apache Hue, for example, which you would imagine would do something like this, doesn't yet support it. I could be wrong as of today, though I haven't seen it in a little while. It tends to be a pretty useful thing if you have an ODBC or JDBC data sources that you want to expose from inside your Hadoop cluster, which can then be used for some of the self-service business intelligence tools. The point being some. Not every tool can connect using this pluggable system. And even if it does, the key thing to watch out for here with the edge proxy gateway is performance challenges. You are using kind of a single reverse proxy as a potential bottleneck into the Hadoop cluster, so transferring, let's say, a very, very large Hive table could result in some issues here. All right, so in summary, we've looked at 4 different methods to securely connect external application software into the multi-tenant Hadoop cluster. At this point, I'm guessing that most of you never want to see another architecture diagram for the entirety of the Hadoop conference. Yeah, so security is complicated, right? Hadoop is also pretty complicated. And today, I see that a lot of the development that's been happening in the community has been trying to simplify this and make this a little bit easier. But nonetheless, even as it stands today, it is definitely possible to integrate open source and commercial tools that provide a lot of great graphical analytics capability into a secured multi-tenant Hadoop cluster. And in conclusion, we've discussed quite a few security architectures today, from authentication and accounts management to authorization and access control, to how to securely integrate software into Hadoop. And I just want to close with one final thought. It's an exciting time to be working in analytics technology. There's a very large number of industries and a very large number of companies making data-driven decisions. But it's also a bit of a risky time. Data breaches are in the news every week. There is something inherently risky about taking a data lake and dumping all the data into it to kind of centralize the data, if you will. But I think with Hadoop, the community has now crossed a threshold where it is now possible to have enterprise security built in and enabled into Hadoop that makes it possible to be relevant on a global scale. And I think it is our duty as technical architects and engineers not to shy away from the security of Hadoop, despite its difficulties, and to ensure that we deploy these analytics capabilities that have both good security and good analytics value. Thank you. Yes.
So your data analytics platform portal looked really interesting.
Yeah.
Is there a lot of custom developed applications
Beneath
that, or is it mostly a gateway to?
There is a lot of custom things developed behind that. Hadoop, for all its enterprise capabilities, does have some missing bits, and so any deployment in an enterprise will most likely require some custom development to make sure that it's easy to use or works the way you think you like it to work. Yeah. Yes.
Could you talk a little bit about like the logical organization of your data? I mean, I guess it's like we've talked a lot of technology about it. Is it kind of like aligned with business unit? Because I mean, I imagine like a data analyst, you said anybody's available in the company.
Yeah.
They hit this portal and then it's like what?
Yeah. So
Data set or?
So I can't specifically talk about that for our company, but generally speaking, there's a class of tool called data catalog capability. You can get these from many commercial vendors. So one idea is that I think what you're getting at is in a large company, it's somewhat difficult to find data sets that are useful from other groups. How do you certify certain data sets? Do you not certify? Do you have a governance process? And so there are capabilities that do that, and unfortunately, I can't talk to you about more specifics, at least in this talk. Thank you. Yes. The question is, did I come across any performance limitations? I think. So I think, the question is, how do we get around the Knox performance limitation? Generally, we try to find another path. It's probably the best answer that I can give you. Yeah. Yeah, it's a, yeah. A direct connection into a Hadoop service. Yeah. Any other questions? What are the major challenges in implementing Kerberos? I think, well, the first one is simply the skill level that's needed. Having administrators, having developers who are aware of Kerberos is a bit of a training process. It takes some time to find good people who have good Kerberos skills. It's also the case that it's also the case that a lot of times when you debug Kerberos issues, it requires help from multiple teams in an organization. When Kerberos is not functioning as it should, it often extends beyond just Hadoop or just one KDC. It often takes having to contact a lot of other groups in the organization who needs to help you debug it, and then that can sometimes amplify the issues with skill involved in Kerberos. And then finally, I would say that secured Hadoop is still not a super mature capability. So sometimes some things like that I mentioned with the authorization surprises, these surprises will happen, even if you fully kind of understand how it works. All right, I think that's all the time we have. Well, thank you very much.